Hello everyone, welcome to Dr. Ravi's Academy. I am Dr. Ravi, Professor of Mechanical Engineering. In today's virtual class, we will be learning the various methods of analysis of vibration problems. Let us look at this. You have three methods of analysis. First one is equilibrium method, energy method, and Rayleigh's method. Let us analyze in detail by means of a spring mass system. So the first method is equilibrium method. In this, let us consider a spring with the stiffness K and mass, let us say M is the mass. So this is in equilibrium. So K is the stiffness of the spring and this is in equilibrium. Obviously, if you draw the free body diagram, so downward is mg, upward force is spring force, that is K into delta. So both are equal. So it is mg is equals to K delta. So from equilibrium condition. Now let us consider vibration. It is deflected by means of an initial disturbing force. Now I have indicated with x the direction of the motion and stiffness is K. Now the displacement is x and let us apply the fundamental equation of kinetics, that is sigma fx is equals to mass into acceleration. So this is the Newton's second law of motion, which is also known as fundamental equation of kinetics. So sum of the force is in the direction of the motion. Now x is downwards, that is the positive direction of the motion, and you have mg is acting downwards, and the spring force is acting, it is k into, it is a delta plus x is the displacement. So it is in opposite direction, minus k times it is a delta plus x is equals to mass into acceleration. So if you expand, you have mg minus k delta minus kx is equals to mx double dot, and as you know these two are equal and cancel, and if you rewrite mx double dot plus kx is equals to 0, or you can keep in the standard form, that is x double dot plus k by m into x is equals to 0, and this is what is your radian frequency, that is omega n is equals to under root, it is k by m, and the natural frequency 1 by 2 pi into k by under root k by m. So this is the natural frequency of the system, spring mass system, by equilibrium method, that is dynamic equilibrium. This is in dynamic equilibrium. Let us look at the second method, energy method. The total energy remains constant. Here you have two forms of energy. One is kinetic energy and the other is potential energy, and you can write down your Ke kinetic energy plus Pe potential energy is constant, and if you differentiate d by dt of this total energy Ke plus Pe, it is constant, it becomes 0. You know that expression for the kinetic energy, it is half mv square. I am writing it as x dot square. This is kinetic energy plus potential energy is of kx square is equals to 0 if you differentiate with respect to the time. Now let us differentiate this expression. It is 1 by 2 m is constant. It is 2x dot, and differentiation of x dot is x double dot plus 1 by 2 k is constant. So this is 2x x dot is equals to 0. You have 2 and 2, here also 2 and 2, x dot gets cancelled, and you have mx double dot plus kx is equals to 0. Bring this in the standard form, that is x double dot plus k by m into x is equals to 0. From this, the radian natural frequency is under root k by m, and natural frequency, that is 1 by 2 pi into k by m. So this is the second method of analysis of spring mass system. Third method is Rayleigh's method. Rayleigh's method is a modified form of energy method only. As you know that when a spring mass system, it will be having the maximum kinetic energy exactly in the main position. and as it goes up to the maximum displacement, there you have maximum potential energy and kinetic energy becomes zero. So that means your maximum kinetic energy is equals to maximum potential energy. That is what is Rayleigh's theorem. So Ke max is equals to Pe maximum. Both are equal at extreme positions. Kinetic energy is maximum in the mean position, so you'll be having maximum velocity, and potential energy will be maximum where you have maximum displacement, that is amplitude. So this is half, it is m v square, v maximum it is r omega, that is amplitude is r omega is maximum of mv square. I am substituting in place of v r into omega, where r is the maximum displacement. Here of kx square, k, x is again maximum displacement, that is r square. Of kx square, in place of x I am taking maximum displacement, that is maximum, potential energy. So now this gets cancelled, and you have m into r square omega square is equals to k r square, and r square gets cancelled, and you have omega is equals to k by m under root, and natural frequency Fn is equals to 1 by 2 pi into k by m. This is by Rayleigh's method, which is the modified form of energy method. So the conclusion is, in this today's virtual class, you have learned that the various methods of analysis of vibration problem. First method is equilibrium. So that is dynamic equilibrium. By writing the sigma fx fundamental equation of kinetics, you have solved the problem. That is what is energy method. This is also known as Newton's method. Second method is energy method. So total energy remains constant. It is conservation of energy principle, and you are differentiating energy with respect to time and equating it to zero, so that you got that natural frequency. And third method is Rayleigh's method, in which the maximum kinetic energy is equals to the maximum potential energy, and from that you got it is the natural frequency, and you can just verify the frequencies are equal. Thank you very much for watching this video, and for more videos, please refer Ravi's Academy. Thank you.